Architecture of a microblogging platform. Requirements: functional, social graph, tweets, timelines, search, notifications, analytics. Technical: low latency, high availability, scaling, reliability, and so on. At a high level, we need to design for following functions: user follow unfollow, post tweet, home timeline, user timeline, indexation, search, analytics, and notification. We would need following services and databases for each of these actions: a social graph service and a graph database for user follow unfollow action, a tweet service, fanout service, and tweets database for post tweet action, a timeline service and a timeline database cache for home timelines and user timelines, an indexation service, a search service, analytics service, and a notification service. All services are modeled as microservices. In this architecture, you can see these services, databases, and interactions between them. A gateway receives incoming requests and also facilitates push notifications. We will go over each of these components in more detail soon. This is the same architecture using AWS services. Let's take a closer look at each component one by one. Microservices are deployed in Docker containers in Amazon ECS, Elastic Container Service. These could alternately be implemented as AWS Lambda functions. Our graph database is Amazon Neptune, while Tweets database is DynamoDB. Redis Cache is used as a timelines database. We will learn more about timeline generation using fanout service later. Kinesis Data Stream is used as a messaging server, while Kinesis Data Analytics provides real-time analytics, for example, identifying trending hashtags. Kinesis Firehose ingests tweets into Amazon OpenSearch for indexation and into S3 for further analysis by Amazon EMR, that is Elastic MapReduce Service. For indexing tweet data, Amazon OpenSearch service is used. Kinesis Firehose ingests tweet data to be indexed into the OpenSearch service. Let's see message flow of a follow-unfollow action. The request is received by Social Graph service, which updates Amazon Neptune Graph accordingly. When a tweet is posted, Tweet service receives the request and it saves it in DynamoDB Tweets database. After that, it ingests the tweet into Kinesis data stream for further downstream activities. Fanout service receives tweet data from Kinesis data stream and processes it to update timelines in Redis cache. We will learn more about the fanout service shortly. Request for retrieval of home and user timelines is received by timeline service, which fetches it from Redis cache. Real-time analytics is carried out by Kinesis Data Analytics. It receives tweets data from Kinesis data stream and analyzes it in real time. An example of this could be to find trending hashtags. It uses an AWS Lambda function to send trending hashtag information to a notification service and also saves it into a S3 bucket. In-depth analytics is carried out by Amazon EMR, Elastic MapReduce service, on tweets data that is written into S3 by Kinesis Firehose. Kinesis Firehose ingests tweets data into Amazon OpenSearch for indexation. And when a user initiates a search, the search service can query Amazon OpenSearch to retrieve information quickly from its indexed contents. We should be able to send notifications to clients asynchronously. For example, trending hashtags may be sent to clients in real time. This is done over WebSockets protocol via the API gateway. Now that we understand the architecture at a high level, Let's look at some important design aspects. Here's an example of a social graph. User A follows no one. User B follows user A, while user C follows user A and B. Each user is tweeting some stuff. We need to store the social graph, the tweets, and have a way to create the home and user timelines for users efficiently. As we have seen earlier, our social graph is stored in AWS Graph Database, that is Neptune. So what does a tweet data structure look like? It will have a tweet ID, user ID, tweet text, path to any media file, timestamp, and so on. Tweets could be stored in any suitable database. AWS DynamoDB would be a good choice for this. A DynamoDB table has a primary key which consists of a partition key, also known as hash key, and an optional sort key. We could use tweet ID as the partition key. Therefore, given a tweet ID, we would be able to extract the tweet contents quickly. However, we also need a way to fetch all tweets for a user. For this, we can create a global secondary index on the tweet table with user ID as the key and tweet ID as another attribute. What are timelines? There are two kinds of timelines, home timeline and user timeline. Home timeline has tweets from users you follow, including your own tweets, while the user timeline has tweets only of a particular user. Here are timelines of our sample users. These are user timelines, straightforward. Every user's own tweets. Next, let's look at home timelines. The home timeline of user A consists of only his tweets as he follows no one. User B's home timeline has user A's tweets and his own tweet as he follows user A, while the user C's home timeline has user A and B tweets and his own tweets as he follows both user A and B. Generating these timelines every time on user request can be slow. To address that, we pre-generate these timelines by using fanout service. Let's take a look. Now, let us understand the fanout service. This is the fanout service flow. When a user X tweets, the tweet is first saved. After that, the fanout service updates the user timelines of user X in cache. Next, it looks up all followers of user X from social graph and updates their home timelines. However, there are exceptions to this flow. What happens when a celebrity or a person with millions of followers tweets? Updating home timelines of so many followers would be inefficient. Therefore, in such cases, updation of home timeline of followers is skipped. Instead, celebrity tweets are embedded into the home timelines at the time of timeline retrieval. As a further optimization, updation of home timelines of inactive users can be skipped too. Therefore, the fanout service processes tweet data that it receives from Kinesis data stream and updates timelines in Redis cache. Redis cache is a good choice for keeping the timeline data. Here's what the key value structure for user and home timelines may look like. In case of user timeline, key is user ID with UT as prefix, while the value is list of tweet IDs of that user. In case of home timeline, again user ID is the key with HT prefix, while value is list of tweet IDs of all users he is following along with his own tweet IDs. Given a list of tweet IDs, the tweet database can be queried to retrieve the tweet texts quickly. So that brings us to the end of our discussion. This should give you a good idea of how to architect a microblogging platform.